Right, good morning, everyone. We're looking here at astronomy today, again, in relation to meteors, meteoroids, meteorites, asteroids, comets, the whole lot. Okay, so today our focus really is on being able to explain and define what these different objects are, these different celestial bodies. We're looking at also an experiment here that you're going to try and work on at home, which is to investigate the effect of meteor elevation, which means height above ground level, and its impact on rather its effect on crater impact. Okay, so we'll talk about that more in a second. Now, this video, I'm going to send it on to you. It's really good. It talks about the different types of celestial bodies in our solar system. Okay, what you need to think about there are just three keywords that you saw in the video, two interesting facts, and one question that you may have. Okay, write all of that down into your small copy. So, having seen the video, you probably saw that representation there of a comet. And what you would have noticed here from the video is that a comet, when it comes near the sun, what happens is the comet the starts to glow with a tail. Okay, and this glowing tail really is like gas that's reflecting light. Okay, so when we define a comet, we say that a comet is a celestial body. It is made of dust, rock, and ice. Okay, the outer layer is ice, and it glows with a tail when orbiting a star. Okay, so comets are very like a meteoroid or an asteroid, but their comets are quite small. They're similar in that they have rock and dust, but the interesting thing about the comet is that it has an outside layer of ice most of the time, and that's why they're often called dirty snowballs. This is what they look like. Okay, um, the comet will orbit a star just like every other celestial object. But when we talk about the celestial object that is a comet, when it goes around a star and it gets really close to it, it produces what we call this coma, which is this glowing tail. Okay, so that's why we define them there as a celestial body made of dust, rock, and ice that glows, producing a tail when orbiting a star. So you need to learn off this definition here. So some other interesting facts about comets. Well, a comet is found in our solar system, mainly in what we call the Kuiper belt. Now, the Kuiper belt here is kind of beyond Neptune. Okay, so it is where most of the comets in our planet are found. So it's actually quite far away from us in general. The most of the comets. Okay, so thankfully that's a good thing. So comets, we know as well, have a very unusual orbit in that if we talk about planets, for example, the nearest planet to the sun there would be Mercury, and the next would be Venus. Well, if you look at the orbit there, which is the path they're following, it tends to be quite circular in shape. Okay, it tends to be quite circular. But if we look at comets then, and this is representing a comet, Halley's Comet, you might have heard of Halley's Comet. This Halley's Comet here is less circular and more oval in structure. Okay, and we call that highly elliptical, meaning oval-like. Okay, so that's another interesting fact there about comets, is that they have quite an oval-like orbit. We know that comets, when they orbit near a star, as I said, the ice, which is on the outside, this snowball, dirty snowball, remember, it gets so warm instantly that the solid ice does not change into a liquid, but rather it changes into a gas straight away in an instant. And this is called sublimation. Okay, you might want to look this up on YouTube. It's actually quite interesting if you look at what we call dry ice and how dry ice changes directly into a gas. Okay, but anyway, this creates what we call a thin atmosphere, which is called the coma. So this thin atmosphere here, which reflects the light and causes this glowing tail, as we said there. Okay, so that is a comet in general. That's what you need to know about a comet. This is a really interesting video here that I'm going to send on to you. It's from the European Space Agency, and it's how you would make a comet. Okay, so it's really, really very good to explain what a comet is made of and what it looks like and its different properties. The next thing I'm looking at here is what we call meteors. So a meteor is essentially just a rock. Okay, it is a rocky object that would orbit, that would have entered Earth's atmosphere. There are different sub branches of meteors. For example, the meteoroid is just the rocks that would be floating in outer space. So they are just orbiting the star, which is the sun. And then you have a meteoroid. Once it has passed our atmosphere, then it is now called a meteoroid. It has passed through Earth's atmosphere. So this here technically is not a meteor, but it's a meteorite because it's already passed our atmosphere. So once the meteor enters the Earth's atmosphere, it's called a meteor. Once it has passed the atmosphere and it's kind of getting down closer to the planet, it's called a meteorite. And the meteoroid then is the rocky object that floats about in space. So a meteor, what is a meteor really? It's just a rocky object that has entered our atmosphere. A meteoroid and a meteorite, they're all the same. They're basically rocky objects, okay? Now, the interesting thing about us is that we are protected here with this atmosphere. The atmosphere is a big, thick atmosphere on Earth. And you might know that from maybe documentaries or whatever, that a meteor, when it enters our planet, it burns up really quickly, and that's because the atmosphere causes something we call friction. We'll be looking at this in second year, but friction is what causes, if you rub your hands together, that's friction, and friction generates heat, and the heat is so high actually that it actually turns this solid rock directly into a gas, and that's why most of the meteors that reach our planet actually are burnt up in the outer atmosphere. They never become meteorites because they don't get the chance. So that was what I was explaining there, and these guys are often called shooting stars. Okay, so this is what we would know as shooting stars. The next thing then is an asteroid. Okay, so asteroids are really, really big objects, and in our solar system, we have what's known as the asteroid belt between Mars and Jupiter. So this asteroid belt is where most of the asteroids are found in our solar system, which is nervously close to Earth. But the asteroids here are essentially irregular rocky objects, like you can picture them like this, only they're very, very big in general. Okay, they are smaller than planets, but as they get bigger, they're kind of getting bigger and bigger all the time over long periods of time, really. But they're eventually some of them might become planets. Okay, so these big, massive boulders are orbiting out in space, mainly in the asteroid belt, as we said. And asteroids, as we know, are associated with kind of mass extinctions. Okay, so there's a big question: is did these actually kill the dinosaurs? We know from fossil studies that dinosaurs did exist, but were asteroids the main reason for that? We reckon they were, but there was probably a combination of factors there as well, besides the asteroid. But the asteroid may have been basically the asteroid hitting the Earth may have been the event that started it all off. So the next thing then to consider is how is life on Earth protected against different sort of conditions, like for example celestial bodies. How are we protected against asteroids, comets, meteors? How are we protected against UV radiation, which causes dangerous things like skin cancer? And how are we protected from the extreme temperatures that you see on other planets? Okay, so what you'll do is you'll brainstorm for that for 5 minutes in your small copy, and I'm going to proceed now with a few different answers to that. So the main things here, anyway, is that we have an atmosphere which is so important for our planet. What it does is it acts as a barrier to all the harmful radiation. You might have heard of something called the ozone layer, which basically absorbs the UV radiation and prevents it from getting to the surface. The UV radiation, which is associated with skin cancers and other things like that, which are terrible. So we are protected by our ozone layer in our atmosphere, which protects us. We're also protected by extreme temperatures because this atmosphere also acts as like a barrier to extreme temperature. It basically reflects a lot of this radiation back out into space, so it doesn't reach the planet. And that means our planet overall has an average temperature of about 15 degrees Celsius. and it doesn't experience the extreme temperatures we see on other planets. Okay. The next thing then is that the atmosphere, because it's so thick, it'll actually burn up a lot of the celestial objects that fall into our atmosphere. So most of the objects like space debris, like for example from satellites or comets, or not asteroids, but comets, or smaller objects like for example small meteorites that seem to fall into our atmosphere, they will burn up because of the high friction. So that's how we are protected and how life has been protected all this time. Okay. We know as well that Jupiter has a big role as well in our solar system because it's so big. It has a big gravitational pull, which basically pulls a lot of the asteroids and the comets and the meteors down onto the planet, and basically it affects Jupiter rather than the Earth, which is a good thing. Okay. I'm going to talk about this investigation next, so just have your copy out in front of you.